Video number 237, converting fractions to decimals. Convert each to a decimal. Well, these first three on this first page can quite easily be changed to a decimal because of the way we pronounce fractions, at least for the first one. Well, 7/10 just means to put a 7 in the tenth position in the decimal, and in the first digit past the decimal. So therefore, we'll get 0.7, 7/10. Now 19 over 20, we can do this a couple different ways. We're going to show you. You can actually divide this down to a 10, divide both the numerator and denominator by 10, by 2. Divide 19 and 20 by 2 to get you down to 9.5 over 10. But you can also convert that to the hundredths as well. So we're going to see that worked out. And of course, we can multiply both top and bottom by a 2. Let's see how it all works out. And the first one, like we said, is 0.7. Here, if we were to divide both the numerator and denominator by 2, we would have 9.5 over 10. Now, this is a little unorthodox. However, 9.5 over 10 is simply it's 95 100ths, because you'd have 9.5 tenths. That's exactly what this means. You don't have 9 tenths, you have 9.5 tenths. Okay? So that's how you could do this. Another thing you could do is multiply both the numerator and denominator by 5 to give us 95 over 100. So therefore, 95 100ths. We also have 49 over 50. You can multiply both by 2 to get us up to 98 over 100. So therefore, 98 100ths. Next one, divide. Well, we have 7 over 12 and 3 and 7/15. We're going to take a look at how each of these are done on different pages here. So let's look at the first one, 7 over 12. We're going to divide 7 divided by 12. Even though 12 does not divide into 7, we're going to go ahead and get the decimal, the piece of 12, the amount of pieces of 12 that divide into 7 in the decimal form. So the first thing we would do is change the 7 to 7.0. So now we have actually, we're going to put a few zeros here. We're actually going to end up putting, well, we're going to put as many as we need, because we're going to get what's called a terminating decimal, meaning the decimal is going to continue to repeat. So let's go ahead and divide that 12 in. We're not going to use 12 into 7. We're going to go 12 into 70. And that happens, of course, 5 times, because 6 gives us 72. So therefore, 5 will give us exactly 60. Then we subtract and get 10. Then we bring down a 0. Notice how I put the decimal in the solution, into the quotient. There's a decimal here, so I move it up into the quotient. Then I subtract. I got 12 into 100 goes 8 times to get us up to 96. Then I subtract and get 4, bring down another 0. So this one's been brought down. Now this one gets brought down. Then I'm going to go 12 into 40. Well, that's going to go 3 times, because we land right on 36. Then we're going to bring down yet another 0, because we don't see this terminating pattern. Whenever you do divide two integers, you will see a pattern at some point, because they're called rational numbers, which we're going to get to that later. But we do go ahead and subtract 4, bring down another 0, and look what's happening. We're continuing to land on 36, which is causing us to land on 40, because we subtract, and it's causing us to have these extra 3's. So therefore, we would say that 7/12 equals decimal point 583 with a bar above the 3, indicating that this 3 is going to continue throughout the decimal if you were to continue dividing and bringing down more and more zeros. So this is called a terminating decimal. The 3 is a terminating decimal, so the solution is 0.583. Okay, let's move on to the 3 and 7/15. Now in this problem, we can actually do this 2 different ways. We could call this 3 plus 7/15, which would cause us to try to divide 15 into 7, which we would do just like we did the last problem. We're going to put our zeros out here and see what kind of terminating decimal we get. We're just going to tack on that 3 afterwards later on. So 15 goes into 70, well, 4 times, because we land on 60 again. We got a 10, then bring down this 0, so now we have 100. How many times is 15 going to 100? Well, let's see here. Not 7 times, because 7 times 15 is 105. So therefore, we're going to go 6. So then we get, that's 90, of course, and just subtract, bring down another 0. And then look at this. We get another 100. So we're going to, looks like we're just going to continue to get a bunch of 6s here, because we're going to keep getting 90s. We're going to keep getting 10s. So therefore, we can say that 3 and 7/15 equals 3.46 with the repeating symbol above the 6. All right. Now there is another way we could have done this problem. We could have converted the mixed number into an improper fraction, 52/15, and we wouldn't have to have worried about adding that 3 afterwards. So we would just go ahead and divide 15 into 52, and that would definitely go 3 times so that we land square on 45. Let's put a bunch of zeros here. It doesn't matter how many we put. We can always stop bringing them down whenever we see the terminating decimal. So now we got the 3 goes in there, 15 goes into 52 3 times for a 45, giving us, let's subtract and get 7, then bring down the 0. And then 15 goes into 70 how many times? Well, 4, because we're going to land on 60. Then we're going to subtract to get to 10. Then we're going to bring down this 0 to give us 100. And then here we're going to get that 6 again. And we're going to keep getting the 90s, the 10s, and the 100s. So therefore, we could say that it's 3.46 with a repeating bar above the 6, indicating that the 6 is a terminating decimal. All right? So there you have converting fractions to decimals.